So there will be some problems where you actually have to draw up your own network. You'll be given some information, but it's really just from a table. And the table might tell you, for instance, the distances between cities or locations. So for instance, if these are all in kilometers, you can see that traveling from A to B, because that connects A and B, is 5 kilometers. And so we, looking at this table, have some information, and you can see that I've got 6 nodes that I need to connect in. So it doesn't matter how you do it. I'm just going to put them in, and I'll probably just write the letters. I've got A, B, C, D, E, and F. You could do it as a box, as a grid, as a straight line, anything that you want. There's no right or wrong way to do it. But you just pick in your own points there, or your own locations for those nodes. And another thing I want you to keep in mind is that you're going to cut this table in half. So we're going to cut it in half, and we're going to ignore part of it. And the reason we're doing that is because it's symmetrical. You'll notice it shows us the distance between A and B here at 5, but it also shows us the distance between A and B here. Much like the distance between F and B is 16, here we can go between B and F is 16. So it's helpful with this table if you just ignore half the information. So what I might do is just ignore this. And that way I make sure I can get all the information on there appropriately. So next thing I'm going to do is draw in my network and my distances. So if there's a gap, that means there's no connection between them. So I'm just going to look at the numbers and say, okay, going from A to B is a distance of 5. And going from A to C is a distance of 6. So from A to C is a distance of 6. I write that below the line, distance of 6. And that's all my connections out of A. So looking at the next option, from B to D, so going from B out to D, I'm going to have a distance there of 10. So from B to D is 10. And from B to F is 16. So from B over to F is a 16. Looking at C, again, I've ignored this first half of the diagram. So from C out to D is going to be 7. So from C to D is 7. And from C to F is 15. So from C to F, going through the network here, 15. From D to E is 9. And from E to F is 8. So that has completed the network for me. So that's the first step. I've drawn my network and shown all my edges and the distances between them. Now my next thing is then to find the minimum spanning tree here, so the minimum path between A and F. Sorry, I misspeak there. Here we just want to find the minimum path between A and F. So this is the shortest path, and we can use something like Dijkstra's algorithm to try and figure that out. So one thing I might do is copy the diagram for myself before I muck it up. Because I see here I have to do a second problem, so find at least one Hamiltonian. So we'll look at the second question first here. Question number 2 here, the minimum path between A and F. So I'm going to start at A, and I want to end at F. So here I'm thinking about possibly using Dijkstra's algorithm. So if I go from A to B, it's a distance of 5, and from A to C is a distance of 6. And if I go from B to F, that's a distance of 5 plus 16 is going to be 21, so B 21. Let's double check out here. If I go from C to F, that's a distance of 6 plus 15 is going to be 21. So C 21. So let's see if there's anything else possible here. If I go from A to B is A5 there, and then here I've got 15, so that's B 15. And from there, connecting back in, I can see that I'm going to end up with a lot. So it looks like I might actually have 2 possibilities here that are equal. And just to double check that again, 15 plus another 17 is going to be really big, so this is not going to be a possible route. We'll cross it out because it's already bigger at that point. So I've got 2 equal distances. I can go A, B, F, at 21 kilometers, or I can go ACF at 21 kilometers, so they're equal. So maybe you could look to see which path is actually prettier or nicer to drive or has a good coffee shop along the way if you're going to get between A and F. So looking at question number 3 here, find at least one Hamiltonian circuit in the network and calculate how long it will take to complete. So at least one, but there will be a few in here that we can get at. So again, reminding ourselves a Hamiltonian circuit is starting in one place and finishing there. And it's just about getting to the nodes, not worrying about what paths you take. So let's go A, B, F, E, D, C, A. And being that a circuit, I need to start and finish at the same spot. So this was my start / end on A. That was one possibility. Let's see if I can do something else here. What if I go from starting at D? Could I do D, B, A, C, F, E, D? Yep, that's another possibility there with my start and end at D. So those are two possibilities, at least, within the circuit. I'm looking again to see if we can find another one. Let's try starting at C. See what happens here. So if I start at C, let's try C to F, E, D, and then from D, let's go out to B, A, and back to C again. So that is another distinct route. It's different than the others, so start / end on C. So if we look at our distances, first one we did was A, B, F, E, D, C, A, and if you add all those up, you'll get a total of 51. And then the next one that we looked at, starting at D, was D, B, A, C, F, E, D. And if you add up all those distances, you get a total of 67. And the last one we just did, starting at C, C, F, E, D, B, A, C, and if we add all those up, you'll get a distance of 53. And I've been talking about this as kilometers in this video, but I realized that in my problem I actually told you it was seconds, so in this case, if we actually follow the question, the units here would be seconds, which makes these should be seconds as well. So those are 3 possibilities for the Hamiltonian circuit there, and the distances around to complete them. So that's your exercise for actually drawing a diagram from a table. Remember, just kind of ignore half of it. Put your points for your nodes anywhere you want, and just make your connections and put in the numbers, and from there you can solve the problems.